Hey YouTubers, welcome back to my magnetic field physics lesson, hopefully simplified and compact for you guys. I'm going to jump straight into the problem. That's what I couldn't fit in the first video, or one of the first problem. I have two or three I'd like to get to. I'm going to read the problem, and I was talking about my methodology to solving problems. After I read the problem, I'm just going to state, or I'm going to write down for you guys the essential variables and the essential known things, and then I'm going to write down the unknown variable, and then we'll go from there with our formulas. The problem is this. A proton travels with a speed of 3 times 6 meters per second at an angle of 37 degrees with the direction of the magnetic field of a magnetic field of 0.3 Tesla in the positive y direction. What are A, the magnitude of the magnetic force on the proton, and B, its acceleration? Okay, so erase this. I'm going to start off by writing all of our essentials here. Again, I have it on paper. I haven't exactly memorized the formulas or individual problems. I'm going to write in this upper corner here our essentials. This is essential in a lot of problems here, whether you get a proton or electron, because remember, the force of the magnetic field acts differently on electrons and protons. So we're writing that down. The velocity of the particles, I'm actually not giving myself enough room there. The velocity of the particle, make that T, equals 3 times 10 to the 6th meters per second. Then we got the angle theta at which the particle is traveling, and that's 37.0 degrees, and that's going to be measured from your x-axis going counterclockwise, 37 degrees. And the magnetic field, and I'm just going to write MF to notate magnetic field here, or I could just write B. That's the actual proper notation. I'm still figuring this out myself, guys. It is in positive, that's going to be for positive, y direction. Probably should notate that shorter too, but oh well. With magnitude, just going to write MAG for magnitude, of 0.3 Tesla. And what we're asked for in the problem, or for part A anyways, is the force of the magnetic field. We're asked for FB. So what is FB? That is our pertinent information. I'm just going to box that. I know that takes up a lot. I write kind of big. Still getting better at that. Writing things out so that I can all be on the same board. And actually starting to solve this problem, we're just going to go straight to the formula. So this is just asking for magnitude of the magnetic field. If I said earlier vector form, I was mistaken. Just the magnitude. So we don't care about direction. So we don't need a cross product, which is good because that's a little bit more complicated. We just need the numbers here. We just need to do number crunching. So we're going to start off with our formula. Our formula is, if I can get this marker, let's see. I'm going to try my blue marker really quickly, see if that does any better. That might actually have some more, and that'll be a little bit more distinct. So we got our givens over here, and on this side we're going to have the actual problem solving in the formula. So this is our A part up here. So the magnitude of the magnetic force equals the absolute value of the charge, and this is a given. An absolute value, we don't even need to know if it's an electron or a proton. We just need to know the numerical value for the charge, because remember, they're one and the same. And it's actually, the number is 1.60 times 10 to the negative 19th coulombs, and that is the same for a proton, for electrons. So we don't even need to know what it's for. We just need to know that number, which we have from our book. Then we have velocity of the particle times the magnetic field, just its magnitude, not direction, times sine b. And that's actually the angle that's going to be formed between these two quantities. And let's see here. These numbers actually come out to be, I'll write these numbers out for you guys. I just stated that the Q is 1.60 times 10 to the negative 19 coulombs times 3 times 10 to the 6th meters per second. And I'm going to just continue this down here because I'll write way too big. And that is also times 3.0. You know what? There's no need to put a 3.0. I don't need that. Sig figs. Times 10 to the negative 1 Tesla times sine 37. Okay, so before we actually, I've already calculated the answer to this. Before we look at the answer to this, though, let's identify this. Well, this is our absolute value of Q in our formula. We're just going back to our formula up here up top. So this number here is our absolute value of Q. This number over here is our V. This next number here is our B. This is the magnitude of the magnetic field. And this is theta, or this is sine theta up here. So as you can see, this is our simple algebra. We're following this exact formula here. And what this will give us is 8.67 times 10 to the negative 14 newtons. And newtons would be, and that is the magnitude of the magnetic force. And newtons would be the proper unit for any force. Or kilogram meter per second. But we're not going to talk about deriving units because I don't know enough about those. I need to watch a YouTube video before I can make a YouTube video on those. But that was the A part there. And we're still sticking with the same fundamental information for the B part. And the B part asks for acceleration, if you don't remember from me reading a few moments ago. So we're looking for the acceleration of the particle, actually. So, and we can determine that by knowing, because we just solved for, I erased it, but we just solved for, and I'll actually go ahead and write that again because it's needed, I shouldn't have erased it. The magnitude of the magnetic force, which is simply that, and with that being said, we're looking for acceleration. So we also have in our handy dandy textbook, and this just comes from knowing what's in your book and knowing your formulas, we have the mass of a proton, which is slightly different in an electron. And well, let's see, we got a force and we got a mass. Let me actually write this mass down here really quickly. It is, I'm just going to write MP, that's mass of proton, 1.67 times 10 to the negative 27 kilograms. And so we have force and mass, and wouldn't you say it's Newton's second law, F equals ma. This guy's stuff is just in everything. It's amazing. This is magnetic fields, and his work applies here. It's just wild how much stuff how much stuff is applicable to his work, or how much stuff his work is applicable to. So we're looking for A, so we're just going to divide that in. Again, being explicit, guys. I know most of you know algebra, but just to be extremely explicit here. So with me just doing that canceling, A is going to equal F of B, that's a better B, over M, and we have our M, which is the mass of our proton, we have our FB. If you just divide these numbers out, if you divide, and it's good that I actually wrote them like this, it'll just simply be a division of those two numbers right there. And when you divide those numbers out, you get 5.19 times 10 to the 13th meters per second squared. and that is your units for acceleration. And that was simply derived. Another thing with the physics problem, sometimes you have to solve one part of the problem before you can solve the other. To solve in one part will give you a variable you needed for another part of the question. Sometimes on physics tests, there will be a A, B, C, D part to the question. Sometimes you got to skip all the way down to part E before you can actually solve part A. It's a little confusing sometimes. You can spend a long time on part A, like, what am I doing? 15 minutes later, you realize you wasted 15 minutes when you could have solved E and then solved part A extremely quickly. So that's very frustrating. The next problem I want to talk to you guys about, I'm going to fit in here really quickly. These problems are actually taking longer than I anticipated. This is my first video, or second rather. My time management, my YouTube time management's not that good. My real life time management's not that good. So yeah, my YouTube time management's definitely not that good. The next problem actually is a proton moves with a velocity of v equals 2I minus 4j plus k meters per second in a region in which the magnetic field equals B, or the magnetic field is B, equals I plus 2j minus 3kt. What is the magnitude of the magnetic force this charge experiences? Well, instead of going through this entire thing, I'm just going to explain the general process of this. So what we are given is we're given unit vectors. I'm sorry, and I write my unit vectors a little bit differently than some people just because I'm lazy. That's right, lazy physics major. I know that's like a contradiction or something, but that's me. And what we're given is these, and the way to we're going to end up having 9 different things going on when we set this up as a matrix. And the way to do determinants, I'm actually going to link you guys to a video that will explain how to do these. There's a big formula given, but what will happen is when you do the determinant for this, you're going to end up with your k's. And just trust me on this, when you watch this, guys, if you plug in these numbers, if you watch the video I'm going to link you to, and you plug in these numbers, what's going to happen is your k's are going to cancel. I'll do it for you if I had time in this video. Your k's are going to cancel, and then you're going to end up with just 10I plus 5j. And by the way, unit vectors, they're just simply there for convention of direction. I is for the x direction, j is for the y direction, and k is for the z direction usually. But it's not a necessity. But for all I've seen, problems I've seen, that's how it has been. So maybe it is a necessity. Maybe I'm wrong there. But so you have these two. So now you just have see, this is in respect to x. This is y. So you have those. We have this handy dandy formula over here. Hopefully you guys can see this. If we want to find, remember our original problem stated we're looking for the magnitude. So if the magnitude of the magnetic force on the particle. So this is just a general form of this equation here, and it can be applied to the force, the magnitude of the magnetic force, and you end up plugging in these numbers here into this here. Let me make it a little bit more specific. If you can see these arrows, hopefully i's into x's, j's into y's, and you get FB equals 11.1 newtons. So that is the general method. I'll link you guys to a video showing how to do determinants. It's a wonderful video. It's more, if I wanted to include it, but it would have been more so a calculus, or no, I'm sorry, not calculus, just an algebra lesson than a physics lesson. But that concludes this 2-part series on magnetic fields. Let me know what you think. Let me know how I can get better and help you guys. This is to help me learn, but this is also to help you YouTube. You physics students who hate it, you physics students who love it, you physics students who don't really care, who just rather eat a sandwich. Just let me know how I'm doing and send me any questions or comments. Thanks.